Hi, my name is Christopher Donnelly, and today I'm going to talk to you about value engineering. Just a quick overview of what we'll be talking about today. What is value engineering? Why should you use it? When should you use it? How do you use value engineering? Where does value engineering fit into the real world? What is value and how do you calculate it? It's not as simple as it sounds. Methodology and structure of value engineering. Who benefits from value engineering? Now first, what is value engineering? According to the Cambridge English Dictionary, value engineering is defined as the process of reducing the cost of producing a product without reducing its quality or how effective it is. Now I want to emphasize it's reducing the cost without reducing the quality, and that's an important distinction. Now a little bit more relevant to our conversation today, according to the Architect's Handbook, value engineering is defined as the systematic application of recognized techniques that identify the functions of the facility, establish the worth of those functions, and provide the necessary functions to meet the required performance at the lowest overall cost. Now again, I want to emphasize it's not simply the lowest overall cost, it's identifying the functions, it's establishing the worth of the functions, and it's providing the necessary functions to meet a required performance, a required function. Now, if you do this correctly, you can improve project quality, improve product quality, reduce project cost, reduce product costs, and maximize the cost-benefit ratio for the stakeholder. And that is why it's been used in many industries since its development. Now, I want to go a little bit into the history of value engineering, and I think that will show you a little bit more about what value engineering is and why it's useful. Now, the United States during World War II was using an enormous amount of resources for the war effort, and by doing that, the United States created shortages of parts, of labor, of raw materials, and because of that, the industrial companies and manufacturing companies in the United States were facing those same shortages. They were forced to find alternatives because those parts and labor raw materials were just unavailable or so in demand that they were cost prohibitive. So General Electric, being one of those companies, began to develop a process for analyzing alternatives. And as they did, they began to realize that those alternatives sometimes led to better products, lower production costs, and faster production, and generally more profitable company. So once they realized this, they began to formalize this and make it part of the corporate culture, the corporate standards. Lawrence Miles, one of the developers of this process within General Electric, after the war, published it. And as companies began to realize this, began to adopt his process, they began to realize how important and how beneficial it was, and it began to spread. And it's used now in construction, in manufacturing, and even in finance. And that's why I like to think about value engineering in terms of capitalism. Because like capitalism, value engineering creates a situation where the best ideas, the best outcomes, the best products and services for the lowest price wins, where the same product is competing with another product of the same function, not necessarily exceeding the function or adding to the function, but if there are two products with the same function, the one that is better for the lowest cost wins. I like to think of an example, pens. You go to the store and you want a pen. You have 500 different pens to choose from. You're seeking one that has a function of just writing. You don't want a pen with a clock, with a flashlight, with a radio. Those are functions that you're not looking for. But you want an affordable pen that can write well consistently, not a pen that will dry out, that will stop writing, that will last you a day. You want a good pen for a cheap price. What value engineering is not a method of cost cutting. Cost cutting often sacrifices function or quality. In the case of the pen, a company might want to cut costs on production, and in doing that, they may buy a cheaper ink, use a cheaper plastic or a cheaper quality material. And when you do that, you reduce the quality of the product. You reduce sometimes the function of the product. And that can hurt you in the competitive market, and that will hurt the company and hurt the product. In value engineering is not a design peer review. In a design peer review, you design a project, you design a product, and you send that design out for review from your peers. You check your calculations. You see if you followed the standards. But you're not incorporating the method, the structure of value engineering that incorporates that creative process, that team creativeness. Value engineering is also not function innovation. As mentioned before, we're not looking to add function in this value engineering process. We are looking to keep a function, to accomplish a function in a creative way, in the best way, for the lowest cost. Value engineering is also not an individual task, and I can't emphasize that enough. It is a team effort. It's a creative effort by a team to find the best alternative. So why do we use value engineering? As GE found, sometimes the original or conventional method, design, or idea is not always the best or the most cost-effective. Sometimes, if you incorporate this value engineering process, you'll find an alternative that produces a better product, a better project for less cost. Now, it also incorporates lifecycle costs, which sometimes is overlooked when you are developing a project. In construction, sometimes construction costs account for as little as 11% of the life cycle costs of a major structure, such as a building or a bridge. The rest of the costs, the maintenance costs, or the repair costs, can account for much, much larger percentages of the overall life cycle costs. And the same with manufacturing. The manufacturing investment costs account for only a fraction of the production costs. Labor, maintenance, downtime, production rates, electricity, and much, much more account for a larger percentage in many, many cases. Value engineering focuses on the essential functions of the project, on the basic functions of the project. Why is the project being done? It uses this creative, out-of-the-box thinking, life cycle cost analysis, multidisciplinary framework, bringing in people that you may not have involved in the design process, bringing in the stakeholders, using all of these analytical techniques to identify the best alternatives offers the stakeholder the possibilities of saving money, of producing a better product, a better project. Now, value is the core of value engineering, obviously. What is value? According to the dictionary, value is the regard that something is held to deserve, the importance, worth, usefulness of something, the material or monetary worth of something, the worth of something compared to the price paid for or asked for it. Now, in all of these definitions, worth, importance, usefulness, those things are emphasized, not necessarily simply the cost. Now, in terms of value engineering, value is the ratio of function to cost, or more broadly, worth to cost, or even more broadly, satisfaction of needs to the use of resources. remember, value is something that is measured not only in cost, but in importance, in the worth of something, in the usefulness of something. So in that case, in that sense, it can be a little bit more difficult to keep subjective. So we use a method of comparison. If you think about the value of getting married, there are obviously costs. There's the wedding cost, the anniversary gift costs, the costs of children, of houses. But if you think about the function, the worth, the satisfaction of getting married, the only way that you can quantify that is comparatively. And I'll get into that a little bit later, but I just wanted to mention that it is not simply comparing costs. Comparing worth is a little bit more difficult. And that brings me to the types of value. First, cost value. How much will be spent to produce the item or complete the project? Exchange value. How much can the item be bought for on the open market? What if we just paid somebody else to do the project or produce the product? Use value. What is the value to the owner of the item or the project resulting from the function it provides? What is the value of a bridge to society, to the local community? Use value is the key to value engineering. It is the most broad definition, the most broad way to look at it, and allows for the most options to creatively find the solution to the function. So when should you use value engineering? Simply put, the earlier in the project, the better. The potential cost savings and functional impact of the value engineering process decrease with each progressive phase of the project. In the planning and analysis phase, the potential cost savings of the value engineering process are the largest. You can impact the path of the project, completely impact and change the design of the project. But as the project progresses, as you move into the schematic design, the design development, the design drawings, construction documents, and even into the operations and maintenance phase, the potential for cost savings by using the value engineering process decrease. That's not to say that it completely is eliminated, and actually in large projects in the construction phase and even in the operations and maintenance phase, value engineering can actually have a very large impact. But generally, the earlier in the project, the better, the largest the potential cost savings are. Now, just to illustrate when to use the value engineering, if you look at this chart, earlier in the project, you'll see that the potential savings are much larger. In the planning and analysis phase, the potential savings are the greatest, and as you progress, they decrease. But you can see that it does not reach zero, that there are still potential cost savings to be had later in the project. It's just more useful and more impactful to use value engineering earlier in the project. Now let's talk about the value engineering process and methodology. There are 6 phases in the value engineering process, and each must be completed before the next one can begin. There is the information phase, the creative phase, the evaluation phase, the development phase, the presentation phase, and the implementation phase. In the information phase, sometimes called the investigation phase, the team evaluates the project and product's function, criteria, and design concepts. And the team does this as generally as possible, because if you keep the function as general as possible, you allow for the highest amount of options to meet that function. Now, to do this, to make the highest impact, the team identifies the project's high-cost elements and conducts a functional analysis of those high-cost elements and assesses their cost-worth relationships. And to do that, to address the functions, to identify the functions, the owner should be brought in. The project's objectives and definition of value should be established through communication with the owner and the stakeholders. Now, to put that a little bit more succinctly, there are 5 basic questions that should be addressed during the information phase. What is the project? What does it do? Meaning, what are the functions? What must it do? What are the basic functions? What are the purposes of this project? What is it worth? What is it worth to the owner, to the customers, to the business? What does it cost? Now, once you've collected all the information from the information phase, you can move on to the creative phase, sometimes called the brainstorming phase or the speculation phase. Now, in this phase, the team applies brainstorming methods to develop realistic alternatives to conventional or current design. And to do that, the team uses a creative method and evaluates all the possible options to the problem presented in each function identified from the information phase. Now, once you've completed the creative phase, you can move on to the evaluation phase. And in the evaluation phase, the team evaluates the ideas created in the creative phase. To do that, the team uses a highly structured method to evaluate and rank the ideas subjectively. The ideas are evaluated on cost and how well they address the functions identified in the information phase. The ideas with the greatest potential savings and function improvement, remember, not function addition, are selected to be developed in the next phase. Now, to evaluate subjectively, again, you need to use a comparative method to evaluate value. Now, once you've completed the evaluation phase, you can move on to the development phase. And in the development phase, the team further develops the highest ranking options from the evaluation phase. And this means developing 3, 4, it depends on the project obviously, but more than one option. The team develops descriptions, sketches, and life cycle cost estimates for the best options. The team performs all necessary calculations to provide a recommendation to the stakeholders. And a recommendation does not mean presenting them with one option. It means presenting them with multiple options. It means you have to develop multiple options in this phase. Now, once you've completed the development phase, you can move on to the presentation phase. And in the presentation phase, the team presents recommendations to the stakeholders. The recommendations usually include cost-value analysis, the life cycle cost estimates, sketches, all the documentation and information necessary for the stakeholder to make an informed decision on a path forward. Now, that usually includes a report and a formal presentation. And it should include more than one option again. This is not for you to decide, this is for the stakeholder to decide, and you have to present them with the best options from the value engineering process. Now, once the stakeholder or owner has decided on a path forward, the implementation phase begins. And in the implementation phase, the owner or stakeholder can choose to, again, use value engineering. If they so choose, value engineering can be used to make recommendations during construction, manufacturing, production, maintenance, and so on. The cost benefit of value engineering, of course, as mentioned before, decreases as the project progresses, but on large projects, it can still be beneficial to use. Now, to illustrate the process of value engineering, again, I want to go through an example, a thought experiment. Without going into too much depth, we'll go through applying value engineering to a bridge project. Consider the proposal of a bridge crossing a river. In the information phase, you would ask those 5 questions. What is the bridge? What does the bridge do? What are the functions of a bridge? What must the bridge do? Meaning, what are the basic functions of a bridge? What are the purposes of that bridge? And the next question, what is the bridge worth? Meaning, what value does it add to the community? Does it add satisfaction? Again, what does the bridge cost? Now, what is the bridge? Broadly defined, it's a structure to transport goods or people past an obstacle. What does this bridge do? What are the functions? It allows for trucks and vehicles to pass over an obstacle. It allows for marine vehicles to travel beneath it without obstruction, and it allows for goods and people to travel over the obstacle. What must the bridge do? Now that might be up to the community, to the government to answer. Was the purpose of creating this bridge to transport people and vehicles, or was it to transport mostly people? Again, you have to bring in the stakeholder, in this case, most likely a government agency or official, to help you answer what are the basic functions, the purposes of creating this bridge. Now, what is the bridge worth? You have to ask, what value does it add to the community? Does it add to productivity, to job creation, to the overall satisfaction of life of the residents? And then what does the bridge cost? It could be, just an example, $3 billion. Bridges are expensive. What does it cost to build the bridge, to design the bridge, to maintain the bridge? What are the life cycle costs of that bridge? Now, we enter the creative phase, and we ask ourselves, what else can perform the basic functions of crossing a river? We have different types of bridges: suspension bridge, cable stayed bridge, steel arch bridge, cantilever bridge. Then we move into more out of the box or alternative ideas: tunnels, ferries, helicopters, amphibious buses, pedestrian bridges with escalators. Thinking outside of the box, thinking of alternatives that address this basic function of crossing the river. Now, once you've completed the creative phase, you can move on to the evaluation phase. And in the evaluation phase, you'll basically evaluate all those ideas that you came up with in the creative phase. And that will filter out the bad ideas or the ideas that don't address the functions that you came up with in the information phase. So, for instance, a ferry may transport people, but it probably does not transport goods or vehicles efficiently. An amphibious bus, again, will probably transport people, but not vehicles or goods. Helicopters most likely have a prohibitive cost, and tunnels are probably viable. All the bridge options probably will depend on the span of the bridge. And now that you've been through the evaluation phase and have chosen the best ideas, you can develop those in the development phase. That means, in this case, maybe the tunnel, the suspension bridge, the cable stay bridge. You'll look at the life cycle cost of those options, and you'll look at the ways in which they address the function and how they compare to each other. And once you've completed the development phase, you can move on to the presentation phase. And in the presentation phase, you'll present all of your information to the owner, or in this case, the government agency. The suspension bridge, this cable stay bridge, the tunnel, the original design, you will present all of the options and all of the ideas that you've developed in the development phase, and provide as much information as possible, including drawings, sketches, calculations, comparisons, value analysis. All of that you present to the local government so that they can make the most educated decision with that information. Now, once you've been through the presentation phase and the government has chosen an idea or a path forward, we enter into the implementation phase. And in this phase, the process of value engineering can be used to save on construction, materials, design, maintenance, replacement, rehabilitation, all of these things if the government so chooses. But again, decisions made later in the project have less effect on cost and function accomplishment. Now, to illustrate, again, the implementation phase does not mean that value engineering is useless, is over. Once you've completed the information phase, creative phase, evaluation phase, development phase, presentation phase, and are now into the implementation phase, again, you can repeat the entire process and provide savings on the next phases of the project. The only problem is that the potential cost savings decrease again with the progression of the project. Now, to see where value engineering is implemented in the real world, I want you to take a look at this slide here from the Army Corps of Engineers. Now, the Army Corps of Engineers standard, and this is not rigid, but it is for you to observe, there's 3 different options and 3 different pathways for projects and procurements within the Army Corps of Engineers. For projects of less than 2 million, they don't require value engineering, but for all projects over 2 million, value engineering is required. And that is because the potential for savings on large infrastructure projects from the Army Corps of Engineers, including the construction phase and later on in the maintenance phase and all other contracts, those potential savings are very large, and very large for the taxpayers and for the budget of the Army Corps of Engineers. And this is true for large companies, for small companies. Value engineering is incredibly useful and often cases required. Now, this table, taken from the value engineering report on a project for the Department of Transportation, illustrates the functional analysis of a project, including the function breakdown and the cost and percentage of the project, which means for a roadway, for the streetscape, for those first 2 major items, obviously they can have the largest cost impact. And to see what functions have the largest cost impact, you break each of those major items down into functions. For instance, provide shelter, illuminate roadway, control erosion, create path, improve aesthetics. All of those functions can even further be broken down into cost and impact. In this table, you see a value matrix from the same DOT value engineering report. And you can see how value is calculated and compared. So you see attributes, mainline operations, local operations, maintainability, construction impacts, and then those are weighted based on the impact to cost. The attributes weight 26, 26. You can see that the larger impacts are mainline operations, local operations, but unfortunately you can see that the performance is the same for all of those. Construction impacts are slightly lower weighted, but they have a slightly higher impact on the function, on the performance. Now if you look at this table from the same value engineering report, you can see how it all comes together. How you can see there's 1, 2, 3, 4, 5 options that were developed and presented to the DOT, and you can see the performance calculated in that value matrix of each of those and how they compare to each other, and the cost from the development phase, and the value calculations, the value comparisons. And as you can see, this table demonstrates perfectly how value engineering is not a cost comparison. If you look at option number 1, cost is 15.1 million, but the percent value improvement is 10%. Now compare that to option 3A, where cost is 15.3 million, but the percent value improvement is 11%. Now, in a cost comparison, a simple cost comparison, option 1 would be rated higher, but in value, which takes into account performance, which takes into account worth and satisfaction, percent value improvement is higher with the more expensive option. Because, again, worth, importance, satisfaction of needs, those are all accounted for in value. Now, just to go over a few of the major points from this value engineering lecture. Value engineering is a creative, structured method of reaching an outcome of the highest quality at the lowest cost. Value engineering focuses on function, basic function, the purpose of a project or a product. Value engineering is best executed early in the project where it can have the highest impact on cost savings. Value is the ratio of function to cost, or more broadly, the satisfaction of needs compared to the use of resources. And again, value engineering is not cost cutting. It is not a cost comparison. I hope you enjoyed this lecture. I hope you got something out of it. And I hope you have a great night. Thank you.